Hey guys, today we're looking at 7.4, solving rational equations, part 1. So a rational equation, just like a rational expression, kind of not very originally defined, it's an equation that has a fraction on one or both sides. So obviously we're going to be solving equations, but if one side or both sides have a fraction involved, then this is called a rational equation. And we'll have two different methods that we'll have to solve those rational equations. Today, we're focusing in on cross multiplication, or the butterfly method. When you have two equations, or two fractions that are set equal to each other, what we would have to do, the old-fashioned way, we'd have to multiply, let's just solve by x. We'd multiply the left side by 9 on both sides, try and get rid of x. But when we have a complex fraction where we start dealing with fractions on both sides and maybe x's on both sides, the easy way of doing that, rather than having to multiply by the denominator on both sides, is just through that thing called cross multiplication, where if I multiply top by the opposite bottom on both sides, I end up with an equation that doesn't have a fraction involved anymore, and I can just solve it the old-fashioned way. So here, x times 3 gives me 3x on one side, 9 times 5 gives me 45 on the other side, and then I can just divide both sides by 3 to give me 15 for my solution. Right, that's cross multiplication. Where it'll start to get more complicated, obviously, as we have expressions on both sides, it's going to get a little bit messier, but it's still the same process. I'm still just taking and multiplying my denominator by the opposite numerator and vice versa. So here I'll have to distribute, and I'll show my scratch work here. So my first one, 3 times the opposite denominator of 4x plus 5 has to be equal to 9 times the opposite denominator of x plus 1. So distributing in gives me 12x plus 15 equals 9x plus 9. And now, after that first step there, it's basically a problem we've been doing since first chapter of Algebra 1 and even pre-algebra before that. So now getting my variables on the same side, I'm going to subtract 9x from both sides, gives me 3x plus 15 equals 9. So I can go ahead and subtract 15 on both sides, gives me 3x equals negative 6. So I divide by 3 on both sides, and we get x equals negative 2. Negative 2. Hopefully so far so good. Box 3 starts to get a little bit messier because obviously we've got variables both on top and bottom, and we've got squared stuff happening, so it's going to be a little bit more complicated. But we're still just looking at cross multiplying as our process. So we're still going to start by multiplying numerator by opposite denominator, numerator by opposite denominator. So 6x squared minus 54 is what I get from the left side. 6 times x squared minus 9. I'm going to have to show my work here. X minus 3 times 4x squared plus 12x. Eek. So going through, and I get this is foiling, it's 2 by 2. So x times 4x squared gives me 4x cubed. X times 12x gives me a positive 12x squared. Insides would give me a negative 12x squared. Lasts gives me a positive negative 36x. So kind of weird because, that's still 6x squared minus 54 on that other side. So my 12x squared and my negative 12x squared cancel each other out because they're both 12x squared, but one positive, one negative. So we've got, after I collect up my like terms, 6x squared minus 54 equals 4x cubed minus 36x. So, if I'm going to solve that bad boy, not the only way, but the most common way of being able to solve an expression or a polynomial is move it all on one side, set it equal to 0, try and factor. So to do that, I'm going to have to subtract my 6x squareds on both sides. And I have to add 54. Those cancel out from the left side. That gives me 0 equals 4x cubed minus 6x squared minus 36x plus 54. So from here, I need to try and factor this out, which the only way, without having to use that fancy pants stuff we did back in chapter 3 with like rational root theorem and being able to check with synthetic division of stuff, the most common way of factoring a four-termed thing was factor by grouping. So if we remember, factor by grouping said, hey, I'm going to look at these as in terms of pairs of numbers. I'm going to look at my first two and my last two together, see if there's a GCF between the two of them to factor out, and kind of go from there. So if I did this using factor by grouping, 4x cubed and negative 6x squared have a 2x squared in common. 2x squared. So that gives me x minus, 2x minus 3 from my second parenthesis here, negative 36x plus 54. They have a 9 in common. Actually, they have 18 in common. 18. So that would be minus... Okay, so now that I got my terms collected, I have to try and solve this polynomial. Now, the only way that we know how to factor out a polynomial with four terms is factor by grouping, unless we want to go to synthetic division and start testing out different rational roots and that kind of stuff. And I don't think anyone wants to do that. So before I go ahead and do factor by grouping, something I should notice here, since I'm going to be trying to factor, is that all of these are even numbers. So before I actually try and factor this, I'm going to go ahead and just divide through by 2. I know I'm allowed to do that. It's still an equation. I'm dividing both sides by 2, but that's my GCF between all four of my terms. And make it a little bit easier moving forward. So that gives me 2x cubed minus 3x squared minus 18x plus 27. So there's my polynomial that I'm trying to I'm trying to factor. So now, factor by grouping, remember that told us we're going to go ahead and think of these in pairs. So I'm going to take my first terms, my first two, figure out what's common between the two of them and factor it out, and then do the same thing with my second two. So 0 equals, for my first pair, it's just x squared in common, and that leaves me with 2x minus 3. From my negative 18x plus 27, they both have a 9 in common. But if I made it a negative 9, if I said, hey, minus 9 is what I'm going to factor out, that leaves me with, again, a positive 2x, and this will be a negative 3 if I divide by negative 9. Because remember, for factor by grouping, after I factor out the GCF of each of my two pairs, I want what I'm left with to match. I want them to be the same. So in this case, because I ended up with 2x minus 3 in my first pairing, I want to also be left with 2x minus 3. Since that is the case, I can go ahead and factor out 2x minus 3 that they have in common. That leaves me with x squared minus 9. So finishing factoring up there, 0 equals 2x minus 3. X squared minus 9 factors out into x plus 3, x minus 3. So if I set each of those parentheses equal to 0, which is how I find my solutions, my three solutions, 2x minus 3 equal to 0, I would add 3 and then divide by 2, so 3 over 2. X plus 3 equals 0, I would subtract 3 on both sides, so I get negative 3. And then x minus 3 equals 0, I would add 3 and get 3. Now, as soon as we start dealing with these rational equations, you've got variables where they're in the denominator, and just like those restricted values, I have to check to make sure that none of these would make my denominator 0. So what I have to do is go back to my original problem and plug these in to make sure I don't get a 0 for any of my denominators. So if I look back to my original equation, so I'll go ahead and highlight my two denominators. Looking at my three solutions, positive 3 would make this first parenthesis 0, right? If I plugged in a positive 3, 3 minus 3 is 0. So that tells me that positive 3 can't possibly be a solution. It would make that first denominator 0. And my second denominator that I have highlighted here just in yellow, both negative 3 and positive 3 would both make this a 0, because 3 squared minus 9 is 0. Negative 3 squared minus 9 is also 0. So that tells me, in this case, actually negative 3 and positive 3 are both extraneous solutions. Try to write this a little bit clearer. Extraneous solutions, so I can't include them in my list. Extraneous solutions. So I can't include them in my answer. It's just this 3/2 that would work without making my denominator 0. So that's my only solution. It's kind of weird. Happens every once in a while, but especially where we start dealing with denominators where they're going to be, 0, I have to make sure I check for it. Ooh, that was a lot of work. Okay. Last but not least, box number 4 is a rational model. So this is now kind of an application of a rational equation. In this scenario, we are looking at an alloy. This is just kind of giving us a definition. An alloy is just formed by mixing metals together. Sterling silver, specifically, is 92.5% silver mixed with 7.5% copper. So here what they're asking us is, if we have a 15-ounce bar or collection, whatever, ingot, of 800 grade silver, which they're telling us 800 grade silver is 80% silver and 20% copper. They want to know how much pure silver we need to add to that bar or that mixture in order to turn it into sterling silver. So how we'll handle this problem, since we're trying to add pure silver to that mixture in order to turn it into sterling silver, we need to get it to 92.5% silver, 7.5% copper. But we're starting with a set amount of copper. So what we want to try and focus on is getting it, like our focus should be that 7.5% copper. We want to try and figure out how much copper we have, and then that'll tell us how much silver we need to add to the mixture. So the way that we figure out percentages in general, if we're trying to ideally figure out, not copper, we're trying to figure out a copper percentage to match, the way we would figure out the percent of copper in a mixture is how much copper we have, so the copper weight, and we would divide that by the total weight. If we know how much copper is in a mixture, how much mixture there is total, just the copper divided by the total will give us our percentage of copper. So in this situation, since we're trying to get 7.5% copper, we want 7.5%, and I'll switch my colors up here. 7.5%, which percent means per 100, so 7.5 out of 100. We want that to be our kind of our goal. We want 7.5% copper. Now they tell us that we have 15 ounces of 800 grade silver, which 20% of that is copper already. So of that 15 ounces, 20% of it, which is 0.2 as a decimal, 20% is 0.2. So 20% of that 15 ounces is copper. The other 80% is silver. So what we're trying to figure out here is how much silver we need to add to that mixture in order to get it to be 7.5%, which our total weight right now is 15 ounces. But we need to add silver to that mixture until it reaches that 7.5% copper. So again, we have enough copper to make up 7.5%. We're trying to add more silver to it until it gets to that perfect ratio of 92.5 silver to 7.5% copper. So this is going to be our equation. 15 times 0.2 tells us how much copper is in the mixture already. 15 plus how much silver I add to it is going to be our total weight at the end. So now that we have that set up, we can go ahead and just cross multiply. 100 times that, 7.5 times that, which 15 times 0.2, that's just 3. So we can go ahead and just, rewrite that if we wanted to, but 3 times 100 gives me 300. 7.5 times 15 is 112.5. 7.5 times s is just 7.5s. Obviously, you use a calculator on that stuff. Feel free to do that as well when you're on your own. But now that I have that equation set up, I can go ahead and just solve for s. That's how much extra silver the mixture needs in order to get to sterling. So minus my 112.5 from both sides gives me, what is that? 187.5 equals 7.5s. So I divide by 7.5 on both sides, and we end up with 25. So we need to add 25 ounces of silver to that mixture in order for it to become sterling silver. It's a little bit weird, but again, we have these types of kind of percent problems, these different ratio problems that pop up every once in a while where we're adding mixture, like adding stuff to the mixture until it reaches a certain percentage, and this is how we'd have to handle it. Our percentage is on one side, the kind of the thing we're focused on divided by total weight or total amount is on the other side, and then we cross multiply to solve. So that's all I got for you for 7.4 part 1. The homework down there at the bottom is page 396, 4 through 14, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.